Newton discovered that gravity is universal. And what that means is, Newton discovered that every object in the universe attracts every other object by gravity. Now that attraction is only noticeable when at least one of the masses is relatively large. So, for example, the gravitational attraction between a refrigerator in your kitchen and the oven in your kitchen is comparatively small, because neither of those objects has a very great mass. But Newton's law of gravity can be summarized with this equation here, where the m's represent the two masses of the objects in kilograms, r is the separation between the object's centers of mass, and g is what's called the Cavendish Constant, or the universal gravitational constant. It was determined by Henry Cavendish to be 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. This value of g in Newton's law of gravity is simply a constant, and there's its value right there. A 45 kilogram girl and a 53 kilogram boy are 14 meters apart at a junior high dance. Find the force of gravity acting to bring them together. So we're given the mass of the young lady and the mass of the young man and the distance between them. There's Newton's law of gravity. All the variables on the right side of the equation are known. Please be sure that you square the distance in the denominator. You type that in and check, but I got 8.1 times 10 to the negative 10th newtons, because a force is always in newtons. Now that's a very, very tiny force, and that's because those two masses, neither of them is all that large. When the Earth is involved, one of these masses in the equation is going to be extremely large, and that's going to result in some sort of noticeable force between those two objects. Newton's first discovery about gravity was that it is universal. The law that causes objects like apples to fall to Earth also applies to objects that don't, like the moon. The second was his mathematical formulation of the law. The gravitational attraction is directly proportional to the product of the object's masses and inversely proportional to the square of the distance between their centers of mass. It was up to Cavendish, after Newton's death, to determine the value of the proportionality constant g. So Cavendish turned Newton's proportion into an equality, which you see here in yellow.